Hi everyone, my name is Presley McCarty and today I'll be discussing metamorphic grade. First we'll start with some background information just as a refreshment. A metamorphic rock is a rock that has changed to be a new rock due to intense heat, pressure, or other measures. Metamorphism is a change in the structure or constitution of a rock due to natural agencies such as pressure and heat. Parent rock or protolith is the original rock from which something else was formed. So what is it? Metamorphic grade is defined as the intensity or rank of metamorphism measured by the amount or degree of difference between the original parent rock and the metamorphic rock. Geologists have 4 classification levels, which are very low grade, medium grade, and high grade. The classifications differ based on temperature. Very low grade happens between 150 and 300 degrees Celsius. Low grade happens between 300 and 450 degrees Celsius. Medium grade happens between 450 and 550 degrees Celsius, and high grade happens anything above 500 degrees Celsius. Low-grade metamorphic rocks are generally characterized by an abundance of hydrous minerals, meaning they contain water. As the grade of metamorphism increases, hydrous minerals become less hydrous by losing H2O, and non-hydrous minerals become more common. Metamorphic rocks that form under either low-pressure conditions or just combining pressure do not become foliated. To be foliated means that there are parallel arrangement of certain mineral grains that give the rocks a striped appearance, which is caused by being formed in an environment with either directed pressure or stress. The identification process. What is used? Index minerals that form at certain temperatures and pressures are used to identify metamorphic grades by geologists. What do they provide? Index minerals provide important clues to a rock's sedimentary protolith and the metamorphic conditions that help create it. Sometimes they help form the name of metamorphic rocks, and they're named after the highest index mineral present. Garnet schist, for example, has the high-grade index mineral of garnet, hence the name. What does it look like? So this is a table that shows the parent rock and how they change throughout the different levels of metamorphic grade. Notice how granite does not have any actual change until it reaches high-grade levels. This is because the minerals present remain stable up to several hundred degrees. If you look at mud rock, you can see that it changes during every single form, or temperature, I should say. And sandstone doesn't really have much change until medium grade. Metamorphism that follows. Contact metamorphism is the increase in temperature with little change in pressure. The increase in temperature is caused by molten rock or magma. Relatively pure sandstones and limestones do not typically form new minerals due to contact metamorphism. Regional metamorphism is the collision of 2 plates, which is the source of great pressure and intense deformation of rocks. And if you look, produces greenschist facies, which are low grade, and fibrillite facies, which is medium grade, and granulite facies, which is high grade. So it can do any grade basically. Burial metamorphism occurs when sediments or rocks are deeply buried and exposed to increased pressures and temperatures, which increase as the depth of the burial does. This one produces rocks of zeolite facies. Conclusion. Metamorphic grades allow for geologists to determine the high and low ranges rocks undergo during metamorphism, as well as furthering the knowledge of what rocks transform to during intense changes. The index minerals that are found during the process lets geologists learn what rocks are parent rocks, as well as what minerals are present. They have helped greatly to further what we know regarding the materials on Earth that we share. And here are my sources. Thank you.